Hello and welcome to Section C of the Rheology course. Section C concerns the study of viscoplasticity. I'd like to briefly chat about why the study of viscoplasticity is important. I'd like to show you some examples of viscoplastic materials that you've probably almost certainly come across, and then I'll give you an outline of the next 4 lectures of this course. So, here on my blackboard are a few points of note about viscoplastic materials. By now, we've seen that some materials can exhibit both viscosity and elasticity. And now what we're going to do is to look at materials that exhibit both viscosity and plasticity. So, viscoplastic materials are materials that appear solid below a certain state of stress. However, above this certain state of stress, which we call a yield stress, we find that these materials flow, and they can flow either in a Newtonian or a generalized Newtonian manner. So, if we think about common everyday materials, we can see examples of viscoplasticity everywhere. If you think about the last ice cream you had, a Mr. Whippy that came out of a Mr. Whippy machine, it poured or was extruded out of your Mr. Whippy machine, but then it sat in your ice cream cone and hopefully didn't flop out of your ice cream cone. It might have melted, but that's a different phenomenon. And so the ability of that material to sit in your ice cream cone is a very good example of viscoplasticity. If you think of an ice cream sundae with sort of whipped cream on top, again, whipped cream is a viscoplastic material. We can, for example, spray it out of a spray can and it forms and flows out of the spray nozzle, but once it's been sprayed out of the nozzle, it stays in the shape that you formed it. And so again, that's an example of a material with a yield stress. Other food examples of materials with yield stress might include, for example, bread dough. If you've ever made bread, you'll know that when you're kneading bread, the bread dough is experiencing a flow as you knead it. However, when you shape form a roll or a loaf, it stays in shape. Now, bread dough, of course, isn't simply a viscoplastic material. It's actually a class of materials called viscoelastoplastic materials, because bread dough, as well as exhibiting plasticity, also exhibits a very high degree of elasticity as well. And so I've included this example as a point of note for you to be aware that materials can actually exhibit both elasticity and plasticity together. It's not something that we're formally going to study, but an awareness of that is a good thing. Now, think about laying concrete or laying cement. Imagine a cement mixer coming onto a building site. That cement mixer then discharges a load of cement, and then that cement might get shape formed into, for example, a floor. Now, once that floor's been formed, we want it to stay there. And so what we find is that cements, plasters and concrete exhibit a yield stress. Above that yield stress they flow, below that yield stress they act as a solid. The final example I'd like to give is shaving foam. For those of you that shave, you might spray shaving foam onto a part of your body and then shave. However, the action of spraying or brushing the foam onto that part of your body involves the flow of that material. Once that foam has been put in place, it stays there. And again, this is a very good example of viscoplasticity in action. So, the outline of the next 4 lectures is as follows. In Lecture 10, we're going to examine the Bingham and Herschel-Bulkley fluids. The Bingham and Herschel-Bulkley fluids are different constitutive laws that can describe viscoplasticity. And we're also going to examine viscoplastic pipe flow. In Lecture 11, we're going to develop expressions that allow us to calculate the pressure drop of viscoplastic materials through pipes. And we're also going to look at viscoplastic materials in couette flow. We're going to continue examining couette flow in Lecture 12 and then introduce the concept to you of perfect plasticity. In Lecture 13, the final lecture in this section of the course, we're going to look at how we describe viscoplasticity from a computational standpoint, a technique known as regularization, and we're also going to examine the phenomena of wall slip. I hope you enjoy this part of the course.